Good afternoon. I'm AnjaliKedia, and today I will be talking about the application of context-free grammar in speech recognition. Let us begin by understanding what is CFG. CFG stands for context-free grammar. It is a formal grammar which is used to generate all possible patterns of strings in a given formal language. G is a tuple that consists of 4 elements: V, T, S, P. G is a set of rules that governs the manner in which the tokens of T may be organized into strings in a language. T is a set of terminal symbols. V is a set of non-terminal symbols. S is an element of V and is the starting symbol. P is a set of production rules of certain format restrictions which determine the class of grammar. The Chomsky hierarchy is important in cognitive science because the complexity of a grammar in the hierarchy can be used to evaluate theoretical proposals within cognitive science. As we can see in this chart, the Chomsky hierarchy has 4 types. Type 3 is regular grammar, which is accepted by finite automata. Type 2 is context-free grammar, which is accepted by push-down automata. Type 1 is context-sensitive grammar, accepted by linear bound automata. And type 0 is unrestricted grammar, which is recognized by Turing machine. From these types, we use the type 2 grammar, that is, the context-free grammar. What is speech recognition and why is CFG important? Speech recognition, also known as automatic speech recognition, is capability that enables a program to process human speech into a written format. As we can see in the flowchart given in the presentation, the speech signal is sent, it is pre-processed, the features are extracted, a language modeling is used, and after being decoded, the recognized speech is given out. This is the basic working of a speech recognition system. In this, CFGs are used to model the syntax of natural language and to generate hypotheses about the words and phrases being spoken. CFGs are particularly useful for tasks such as parsing and disambiguation, where they can help to identify the correct interpretation of a spoken sentence. CFG can also be used in development of language models. Language models are used to predict the likelihood of a given sequence of words occurring in natural language. CFG has major applications in speech recognition in 4 areas. We will be looking at each area one by one. Number 1 is the language modeling. Language modeling refers to the process of predicting the next word or sequence of words in a given sentence based on the context of the preceding words. CFG is used in natural language process modeling in the following ways. Number 1, generating n-grams. N-grams are sequence of n words that are commonly used to model the probability of a given word given its context. CFG is used to generate n-grams by defining rules for the composition of sequence of words. Number 2, rule-based probabilistic modeling. CFG is used to define the probability distribution over the space of possible sentences. This distribution can be used to estimate the likelihood of a given sentence and to choose the most likely sentence among the several alternatives. Number 3, contextual understanding. CFG is used to help speech recognition systems understand the context in which words and phrases are used. This includes understanding the meaning of words and phrases in relation to the surrounding words, as well as understanding the overall context of the conversation. Overall, CFG plays a critical role in language modeling for speech recognition by providing a framework for modeling the rules and patterns of natural language and improving the accuracy and efficiency of speech recognition systems. The second application of CFG is parsing. Parsing refers to the process of analyzing a sentence and breaking it down into its constituent parts, including words, phrases, and clauses. CFG can be used in parsing in the following ways. Defining grammar rules. CFG is used to define the rules for sentence structure, including the order of words, types of phrases, and the relation between words and phrases. Parsing algorithms. CFG is used in parsing algorithms that take a spoken sentence as input and output a structured representation of the sentence. These algorithms use CFG rules to build a parse tree, which represent the syntactic structure of the sentence. As we can see in the left side of the screen, we have an example of a corresponding parse tree and a sentential form. Parsing can be done in various ways. Two of the ways are bottom-up and top-down approaches. In the bottom-up approach, we go from word nodes to the sentence symbols, whereas in the top-down parsing, we go from the sentence symbols to the words. The third type of example is the natural language understanding. CFG is used to help speech recognition systems understand the spoken sentence by analyzing its structure and identifying the relationship between words and phrases. Moving on to the third application, we have error correction. Error correction refers to the process of detecting and correcting errors in spoken language, such as grammar and syntax errors. CFG is used in error correction in the following ways. Modeling common errors. CFG is used to model the patterns of common errors that occur in spoken language, and this includes errors in word order, verb sentences, and subject-verb agreement, among others. CFG also provides error detection and correction. CFG is used to detect errors in spoken language by comparing the input to a set of grammar rules. If the input violates one of these rules, an error is detected. Now, if the error is detected, we apply a set of grammar rules to the input to generate possible corrections. It also provides naturalness improvement. CFG is used to improve the naturalness of spoken language by identifying and correcting errors that make the language sound awkward or unnatural. The fourth and the last part of the CFG that we will be looking at is speech synthesis. Speech synthesis refers to the process of generating speech from a text input. The CFG has the following uses in speech synthesis. Number one, text to phoneme conversion. The first step in speech synthesis is to convert the text input into a sequence of phonemes, which are the basic units of sound in a language. CFG is used to define the rules for converting the text into a phoneme sequence. Number two, prosody modeling. Prosody refers to the pattern of stress, intonation, and rhythm in speech. CFG is used to model the prosody of synthesized speech by defining rules for the placement of stress and the modulation of pitch and duration. Number three, synthesizer control. CFG is used to control the behavior of the speech synthesizer, such as the selection of voice, speaking rate, and other parameters that affect the quality of the synthesized speech. In speech synthesis also, CFG provides naturalness improvement. It is used to improve the naturalness of the synthesized speech by modeling the patterns of natural language, including grammar, syntax, and disclosure structure. In summary, context-free grammar is an essential tool for speech synthesis, providing the framework for the rules and patterns of natural language and improving the accuracy and naturalness of the synthesized speech. In recent years, there have been several developments in the use of CFG in speech recognition, including the following. Number one, CFG-based feature extraction. CFG can be used to extract features from spoken sentences that can be used to improve speech recognition accuracy. Number two, CFG-based adaptation. It can be used to adapt speech recognition systems to new languages or domains. And number three, CFG-based deep learning. It can be used in conjunction with deep learning network techniques such as RNNs, recurrent neural networks, and transformers to improve the accuracy of speech recognition. Now, to summarize whatever we've discussed in this presentation, we began with understanding what CFG is and how it is important in speech recognition. We also looked at the Chomsky hierarchy. Then we looked at the four major ways CFGs have application in speech recognition. Number one, language modeling. Number two, parsing. Number three, error correction. And number four, speech synthesis. We then concluded by discussing what developments have been made in CFG in speech recognition in the recent years. With this, we come to an end of this presentation. Thank you.